Welcome to an example of solving an equation with denominators. So they're asking us here to solve for x. Well, how do you do that? How do you solve for x when there's fractions? Let's write out some steps. So solving with fractions. So what we're going to need to do is first off identify the LCD, the common denominator. And what that is the smallest package, that's why we say least, smallest common denominator package that contains all denominator pieces or parts. How about we say it that way? Parts inside. So in other words, what denominator parts are we talking about? Well, this has an x and this has x squared. Those are the only two denominators. Those are the only two things under bars. So we have x and x squared. Those are the two denominators. So I'll say denominator parts. Okay, and so what's the LCD? What's the smallest or least common denominator package that contains them all? Should you say, oh, x and x squared, I better do x cubed? No, that's not the smallest. That does contain them both, true. But x squared itself, I know that's one of the two, but that works, huh? That contains them both. So let me put that back the way it was. So x squared is our LCD because that has in it a single x and it has x squared. They both can go into it one at a time. That's all we care about. That is a package that contains both a single x and an x squared. So that's our LCD. Okay, great. So what do you do with the LCD? You multiply all the terms by the LCD over 1. So, and that's because this is an equation. So I should say left and right sides. Left and right sides. Because what'll be probably helpful to you is to put this line right here for extra clarity. Just to be super clear, we have a left side and a right side which are equal. So whatever we do to one side, we have no choice but to do the same thing to the other to keep them equal, right? If they were equal before and we treat them all the same, they've got to be equal afterwards. So let's multiply through by the LCD over 1, and we know what the LCD is. It's x squared. So I'm going to multiply through by x squared, over 1 right there, and x squared over 1 right here, and x squared over 1 right there. See, all three terms. We can't play favorites. We got to do the same thing to the left side and the right side. Treat them all the same. If they were equal before, they'll still be equal. Okay, so what becomes of this? Well, that's just x squared, right? The over 1 doesn't do anything. Minus. Now, this x cancels that, and we have 7x, right? There's one x left over on the top because there was x squared on the top, and right, this had x squared on the top, and this only had a single x on the bottom, so it canceled, leaving one x on the top. And here, the entire x squareds cancel, and the minus, don't forget that minus sign, minus 12 comes down. Now, so the fractions are gone now. That always gets rid of the fractions. When you multiply through by the LCD over 1, cancel all denominators. So I canceled all denominators. Now, what do we do from here? Now we're going into a different mode entirely. The fractions are gone. Now what? So when you see x squared with an equal sign, what do you know the game plan? A, first get a 0 on one side. And then B, well, let's do that first. Let's get a 0. So I am going to add 12 to both sides. And when I do, these cancel. That'll give me my 0 that I was wanting to get. Whoops, kind of bad. There we go. And the other side will be x squared minus 7x plus 12. Right? These guys have to stay separate because they're unlike terms. Okay, now that's step one, get a 0, and then try to factor, meaning with the 2 parentheses. And part C, if it will not factor, or if you just can't seem to get it to factor, you can always do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's how we handle x squared when it shows up. We get a 0 on one, so it's really important that you have in your notes for the next exam these steps, because it's going to come up for sure and throughout the whole course, and if you're moving on into higher math, it just comes up a lot. When x squared with an equal sign shows up, get a 0 on one side, try to factor. If it won't factor, use the quad. So let's try to factor. Okay, remember factoring a little bit, sort of. What multiplies to be the 12 and what adds to be the minus 7. So what times what is 12? Well, 4 and 3 or 3 and 4, the order doesn't matter. How are they going to add to be negative 7? They got to both be negative, don't they? A negative 4 and a negative 3 add to be negative 7, and 2 negatives multiply to be plus 12, don't they? So that's perfect. Okay, now what? I should have probably added down here. I didn't leave room. Try to factor and then set each part equal to 0 and solve both. Set each part equal to 0 and solve both. Now there's the steps. Definitely put those steps on your notes for the you get notes for each exam, full sheet of notes. So, but here's the trick. It's logic is always better. So yeah, notes, but why? Why can we? So what I'm saying we're going to do here is we're going to take each one of these separately equal to 0. Why can you do that? I mean, logically. Why can 1 equal 0 suddenly become 2? Do you know? Do you know why that's got to be true logically? Think about, what if I told you, hey, I'm thinking of 2 numbers in my head, and I multiply these 2 numbers, and it comes out 0. How can you multiply 2 numbers? That dot is a times there. Let me make that a little bit better. Times. Well, how can you multiply 2 numbers and get the answer is 0? Well, one of them's got to be 0, right? That's the only way you're going to multiply 2 numbers and get 0. Right, exactly. That's what this is saying, right? Because the first one could be 0, and then 0 times anything would be 0. Or the second one could be 0, because anything times 0 would be 0. That's what we're saying. These 2 things, parentheses, they're timesing, to equal 0. Well, if 2 things are timesing to equal 0, that means the first one could be 0, or the second one could be 0. That's just reasonable, isn't it? Math is always reasonable, but sometimes it's hard to find that reason. But once you got it, it'll help you. All right, let's finish up this problem. Add 4 to both sides. So x, got to get x alone, right? And then add 3. So notice the signs switch right at the end. So our answers are 3 and 4. You can say them in either order. It doesn't matter. Those are the answers that make that original equation true. So